Good afternoon and welcome to Birdland Media Works. I'm your host, Danielle Pailly, and today I'm joined by Ira Pastor, CEO of BioQuik, a life sciences company that develops biologic products for both the regeneration and repair of human organs and tissues, as well as the reversion of chronic degenerative diseases. The topic today is science fiction versus science fact, the evolution of the new superhuman. Ira Pastor, thank you so much for joining us today.
Thanks for having me. It's a pleasure.
Oh, I was excited about this topic. So the work that BioQuik is currently doing in the areas of regenerative biology, in reversing disease, in biocybernetics, it sounds like something out of a sci-fi novel. And yet your company seems to be on the cusp of something that's very real and very possible. Can you share with us a little more about you and your work with BioQuik?
Yeah, absolutely. I am a sort of 30-plus year veteran of the traditional pharmaceutical industry. And, while I've enjoyed my time in sort of that segment of the world, I was kind of dismayed by the fact that although we were capable of bringing in, $1 trillion a year and spending enormous amounts, $200 billion annually on new R&D, we were having a pretty poor hit rate at curing any of the major chronic degenerative diseases that are responsible for killing us. We were very good at making treatments for things, but when it came down to actual cures, the last real cure that we ever created was the antibiotic. And so I wanted to get back to something a little more real, a little more earth-shaking that would have an impact on the future. And, when you combine that with sort of the BioQuik mission, which is sort of going back to nature and taking a second look at the natural world and sort of everything that exists on this planet with us, which from a health and wellness perspective is so further advanced than we are as humans, that combined to create the mission of really changing things and doing things a little differently than have been done for the last 100 years.
And in looking at the website, it was overwhelming because I can see this going in so many different directions. Now, on the website, it states that many organisms can replace lost or damaged organs identical to the original, and they can regenerate spinal cord, limbs, hearts, eyes, parts of their brain. And they have the ability to repair and reverse cellular and genetic damage. And you'd mentioned that there are examples of this in nature, but we don't possess that. Can you talk a little bit more about the processes and how they can be made accessible to humans?
Sure. So undoubtedly the audience is aware that many species, the amphibians of course come to mind, have the ability to return both structure and function of complex organs and body segments when they lose them. And so the newts and the salamanders of course is top of mind in terms of spinal cord injury, but as you mentioned, limbs, hearts, segments to the brain, all perfectly capable of regenerating in full form and function throughout the lifetime. What is a little less well known is that many of these same regenerative organisms also possess this fascinating skill for sort of turning back and erasing cellular damage when it occurs. And cancer is a beautiful example of this in the sense that, everything on this planet at one point or another gets cancer. From humans to dogs to snakes to frogs to fish on down. But how some of these lower regenerative organisms deal with cancer is so fascinating in the sense that they, in essence, like to shrug it off. They basically like to turn tumors into normal tissue. And, it affects them like the common cold, but meanwhile sends, 8 million people a year to the grave. So we find these capabilities fascinating. Of course, there's some of the more the outliers in terms of the species that do not age, the ones that like to age in reverse, and even some that die and are reborn. And needless to say, we're very weak when it comes to these things. We do have minor regenerative capabilities. Obviously, we do cycle rapidly, transitioning tissues like blood and skin, and we do have a good wound healing response. But when it comes to more complex forms of regeneration to repair the real critical organs and tissues that, when we lose them, we die, we're not very good at that at all. And so what we seek to do is study the differences between humans and amphibians and many of these other species and find out sort of where we went wrong in the evolutionary scheme of things, and how we can, for lack of a better word, reawaken some of these possibilities in terms of the real big problems that we're facing, in terms of Alzheimer's, in terms of cancer, in terms of congestive heart failure and diabetes, and figure out how to reawaken and tap into these complex regenerative and reparative mechanisms that, unfortunately we can only at this point in time sit and watch the salamanders and newts do. So that is really our goal in reconnecting with this ability that nature created, but which, has sort of slipped past us.
And so I like the word reawaken because it gives the sense that perhaps at one point in time we had these capabilities but lost them. Are you finding that in your research by chance?
Yeah, no, absolutely. I mean, we, obviously from a phenomenological perspective, I mean, there is a reason when you look at a developing human embryo that you see webbed hands and feet, and you see tails, and you see gills and everything else. We do contain, people might not like to hear this, but we do contain the evolutionary past in our genome of everything that came before us. The human genome did not, fall out of the sky. So we have this sort of genetic biologic potential. And then when you look a little closer, you see that there are the vestiges of this type of ability. So, we do see age reset in, of course, human embryos, right? I mean, it is the reason why, I was 30 and my wife was 30 and we got together and, we made 0-year-old children. Time is reset all the time in humans in that one point. It is also the reason why, babies are not born with Alzheimer's disease. The genome is cleaned up before birth. And so we see sort of the remnants of this ability. We also see it in sort of our daily life, behind the scenes. You and I, during the course of this conversation, in the back, very quietly, we're quietly fighting cancer all the time that we're alive. Little transitions that occur in cells, which other cells nudge back into shape, is happening, trillions of times a day across our body. So we do see these possibilities in humans, but on a very small scale right now. We want to boost it up.
Yeah, but this is pretty
and
exciting.
Get back to the really big problems.
This is exciting, the potential of it. And now we're not talking about a pill that's a one-size-fits-all. You don't take it and grow back a lost limb or repair a herniated disc. What's involved with what BioQuik describes as creating the biological regulatory state reset?
Okay, I mean, that's a real fancy way of saying that the interventions to do this type of stuff are complex. You are not going to find a little white pill at your local Walgreens or CVS that you can take to do this. And this has sort of been one of our shifting the way that the traditional pharmaceutical industry thinks about these things. For instance, when we study that poor little salamander who gets its tail bitten off by a predator, we find that there's a lot of things going on. That little salamander is not taking a little white pill to do all that stuff. When we study the salamander, we see that after the tail gets bitten off, that cells that remain in the tail stump reprogram themselves to an earlier, younger state. We see that the body secretes all sorts of interesting proteins that degrade and destroy the dead tissues. We see an activation of the immune system, which helps in the regeneration process. So what we do, we are cataloging everything that goes on and basically understanding how that salamander goes from point B, which is the wounded, damaged part, and turns back time to point A, where basically the signals and sort of the information flow in the salamander say, okay, we need now to build a tail here that is missing. This is known as sort of morphogenetic activity. It is not simple. And so the therapeutics that are going to have to come from this approach, as you say, no, not little white pill, very different looking. And we're going to have to really be thinking differently in the coming years on how this is all going to be administered, because it is not just going to be something that the doc writes a prescription for and, you're off to the Rite Aid to grow your new arm. A little more complex, but in general, that's what's required if you do, in essence, want to turn back time and start over again.
Now, are you in partnership with the CRISPR program, or are you doing something completely different?
No. We don't do genetic engineering,
Okay.
and the reason, and this has nothing to do with CRISPR, and I think CRISPR is a wonderful technology. It is just, number one, inconducive to the major diseases. Obviously, there's many important genetic diseases, but 99% of everything that kills you and me, it has nothing to do with genetic disorders. It has to do with epigenetic emergent properties of the genome. So
Okay.
CRISPR won't be useful for the majority of all that. But in general, we do not genetically engineer because, as I mentioned before, what we are finding, surprisingly, is not that we do not have genes. We're very similar to many species. There's not a lot of difference between us and fish and amphibians and so forth. What they are very good at doing is how they turn the genes on and off to accomplish certain things. And so you don't want to, we don't want to find, here's some gene that's upregulated and pump more of that into you, because very likely that's a gene associated with growth and proliferation and tumor formation. That's not what we want to do. We want to find out what the signals are that naturally modulate the growth, that naturally modulate the shape of a structure. Turn them on at the right time, turn them off at the right time with natural substances like proteins and peptides. This is much more conducive and ultimately, we think, much more cost effective in the long run when you look at some of the costs of these gene therapies that are coming down the pike at $1 million, $2 million a pop. It doesn't make a lot of sense. So we've sort of stayed away from genetic engineering and think there's more cost-effective and intelligent ways to do things.
Yeah. And what you say makes sense. There's a number of studies on Alzheimer's and cancer where people have the whole brew in their body where they should have these diseases and they don't, or at least they don't show symptoms, and they live out their life as if nothing happened. So why does that person go through life with no problem while somebody else is very sick and dies? So it's very interesting. The turning off and on to get things to react the way they should react in the body is pretty fascinating.
What you mentioned, and it's extremely important, are basically the control hierarchies above the genome, which, unfortunately, in sort of a reductionist era like we're in now, where the smaller we get and we keep looking deeper and deeper, we forget about what came beforehand. But in general, genes really don't do anything. They are controlled by higher level architectures of the human body, cells, tissues, even sort of the extracellular fluids and extracellular matrices that tell genes what to do. So, we have these really interesting phenomena in nature where, you see people with mutations out the wazoo, but they never develop cancer. Why? Because, the genes are just a downstream aspect of the bigger picture that we can't forget about.
Absolutely. So now this is going to have a profound effect on the medical profession and the pharmaceutical industry. So, imagine a world where you can cure cancer and Alzheimer's and MS, and where replacing a failed organ is not an issue. And I believe that it would enhance our immune system, you can correct me if I'm wrong, to cure things like migraine headaches and allergies. How will this technology shake things up in the medical community?
It's going to be quite groundbreaking. Thinking, just sort of going to the pharmaceutical industry for a moment, because it's what I come out of, I clearly believe that there will be a bifurcation of industries. While, of course, big pharma has sort of become a marketing shell, in a sense. They don't really do a lot of research anymore, manufacturing or anything of that nature. And they may be useful partners for certain products. At the end of the day, there most likely will be a split between companies that only focus on treatments, as they have done for the last 100 years, and those that are going to promote, sell, market cures. And they may be different. I don't know if big pharma may be the right partner for that, and there may be more specialty pharmaceutical companies that are going to be better at this, that specialize in certain organs, say the spinal cord or the kidney or what have you, when big pharma is more used to selling, as we said, little pills and detailing those things. On the more the broader healthcare side of things, that is going to take some training too, because once again, doctors have been taught by big pharma, about these little pills and bottles. And when it comes to more complex interventions, there's going to be a bit of a learning curve. And now this isn't just for our stuff. It has to do for a lot of the things that are coming down the pike in terms of, living bacteria that is used sort of microbiome therapies, and some of the sort of what we're seeing in the electroceutical space, where they're looking at, promoting devices that just stimulate the drug effect as opposed to taking a drug.
Mm-hmm.
So there's a lot of neat stuff going on, which is going to take a sort of a relearning process for clinicians. But we think that it will not be a steep learn.
So, according to biomedical gerontologist Aubrey de Grey, the person who will live to be 150 has already been born. Do you think we're closer to greater longevity with these advances?
Yeah, absolutely. And, if I know Aubrey, and if you think of sort of that prediction, if we just take a baby born now, as
Mm-hmm.
we're talking, with an average lifespan of today, 77 years for a man and about 80 years for a woman, that takes us out to the year, close to the year 2100 already. So clearly, over the next 80 years, things are going to progress in a fashion whereby it is highly likely that we will reach, if not 150, a bit beyond. And the only thing that really comes up, and it becomes questionable, and it's not on the short term, but it's more on the longer term, is, there's this thing right now, sort of this dynamic where you sort of see that, if you survive heart disease in your 70s and you survive cancer in your 80s and you don't have Alzheimer's in your 90s, you've basically, beaten evolution. In the sense there's not much more that is going to kill you, and that most of these supercentenarian folks that live over 110 years,
Mm-hmm.
very few things bring them down except sort of the obscure that we don't really know about yet.
Mm-hmm.
So it is very possible that 150 could be 200, it could be 250. There could be a no upper end on it if we are capable of wiping out, as I think we are, a broad majority of the chronic degenerative diseases. We might not wipe them all out because there might be things that pop up when you're, 130 that we haven't figured out yet. But I definitely think we can get there as long as we do things appropriately, that we don't fall into the old school traps of developing, drugs that only affect treatment as opposed to cure.
Right.
If we do things the right way and don't fall into those old traps, we will definitely see radical enhancement and longevity.
Yeah. Now, this makes me wonder how society is going to adapt to this. So if people are living longer, how do we provide enough food and water for the masses and don't use up our natural resources? Or are we following Elon Musk and his Tesla Roadster to Mars? Can you take a look at this from a futurist perspective and give a prediction of what society can become through BioQuik's breakthroughs?
Sure. I mean, so, about sort of the overpopulation topic, I mean, I think there's been a lot of work on that front that clearly shows that, as people live longer and healthier lives, the birth rate goes down, and birth rate is definitely much more a function of overpopulation than death rate. Death rate is not a good way to control population, as many evil people have tried in the past. And birth rate does go down quite a lot. Now, that does not mean that we don't have to think about this problem. It just means that we're not going to be overwhelmed with 14 billion people tomorrow. Mm-hmm. I have to believe that a future society, or the one that we're sort of creating, a near future society that is capable of solving these problems of health, should also be capable of solving cheap renewable energy, unlimited agriculture, geo and environmental engineering, and everything that currently is involved with us messing up this place.
You are so positive and optimistic.
I have an optimistic, bent towards, where humanity is going. As far as sort of the Elon Musk vision, I just as a side note, I'm probably not going to get there just because, I can't go on the tilt-a-whirl with my daughter without getting nauseous for about 5 hours. So, if you're going to send me up into space, you better put me to sleep for a long period of time. But interestingly, we are also looking at these things because aside from the regenerative capabilities of many species, you have fascinating capabilities in nature for both cryptobiosis, mm-hmm. so the natural suspended animation hibernation skills of species like bears and small mammals that we're studying, and also what you really need if you do want to follow the Musk plan and get out of here, you better become radiation resistant and, resistant to the other sort of vagaries and perturbations of space. So those are all things that clearly are on the BioQuik drawing board. They're not all coming tomorrow, but they definitely are examples of things that nature and 3+ billion years of evolution has already solved on this planet. I believe we will have answers for those as well if you do want to do the Tesla rocket ship as opposed to hang out here in the underwater city.
So now, are there clinical trials underway? When can we expect these biological drugs to be available, and to whom?
Yeah, first and foremost, to everybody. We set the company up specifically as although we're taking a 21st century look at the world, we based our technologies on 20th century biologics technologies that have been around for the last 100 years. So we realized that we could not develop interventions that only a couple thousand people could ever afford. Mm-hmm. It would not make sense, a la the gene therapies and all this other stuff that people are focusing on. Degeneration, damage, disease, death affects all 7 billion of us. So it made no sense to go into more exotic technologies. So if you or your healthcare system can afford a vaccine or insulin or a traditional therapeutic protein, you'll be able to afford our products. Okay. United States program, we have a 3-year plan for clinical trials, a 5-year plan for registration based on orphan drug status and fast tracking here in the U.S. However, we are also partnering ex-U.S. because even though we are a U.S. company and we love the United States, this is 2018, and we cannot ignore the fact that, whether we're talking about things like, Harvard Medical School operating in Dubai, or Weill Cornell Medical in Qatar, or Newcastle University in Malaysia, global system of medical research has become clearly global. And while, it may have been the structure 30 years ago to do everything in the United States and forget about the rest of the world, you cannot forget about the rest of the world now, because that's where everything's happening. And the really smart people will tell you, if you ignore Southeast Asia or the Middle East or Latin America, you're doing yourself a disservice. So we are partnering up with other groups in some of these regions to begin the first in human clinical experience now. We're doing some spinal cord injury work in India, doing some metabolic work in Latin America to move the programs forward a little faster. And if we can get to market, 2 years faster elsewhere, fine. It is a global market out there for us. And, as I said, this regeneration, repair, and rejuvenation is everyone.
And that's amazing. 3 to 5 years. I expected an answer something closer to 30 years. So you really are on the cusp of some pretty amazing stuff. Is there something we can do to augment what you're going to be providing in terms of lifestyle changes? So will we need to diet and exercise and do all the normal things to protect ourselves? Or are people going to kind of say, oh, well, no problem, we can just turn things on and off and reset?
Yes, you definitely will still have to do things. And this goes back to what I was mentioning about the hierarchies. Mm-hmm. It's no good to take a drug or genetically engineer yourself or whatever the biohacker wants to do, as an example, and forget about what comes above. So exercise, obviously it's good to exercise, but why is it good to exercise? It's good for health. It makes us feel good. But at the same time, when you are stressing your body, when you're stressing your muscles and your bones, those are, not to get complex, but there are forces of mechanotransduction there that trickle down from your muscles through those tissues to the cells to the genes. So it's no good to have a gene that makes you more muscular if you're not communicating with a higher level structure. So it's very important that we're going to continue to do everything. At the same time, I like to mention, while it is not good to eat 3 Twinkies and drink 5 cans of Coke a day, once again, we need to think, as we do this work, about our evolutionary past. We contain the genes of everything that came before us, but as you know, you and I make it, we are not tigers. We do not need high blood sugar levels that were normally seen in diabetes to chase after a prey. So we need to
maybe
remember,
1,000 years ago, but not today.
We need to remember we are human, and we have to eat, drink, live according to this. And the last thing I want to bring up is we are a species that thrives on randomness. Taking X, whatever, 10 milligrams of something every day, it has been shown scientifically is not always as good as taking 5 milligrams one day and 20 the next. That's why we like to vary our diet. That's why we like to vary our exercise routine. Human beings thrive on randomness, and we should never forget that. And because it's not good to become stale, whether it is eating, exercising, therapeutics that we take, anything in life has to vary and give us that, natural sort of fluctuation that our body is constantly adjusting to. Very important.
That's fascinating. And actually that answers some other questions I had on studies on vitamin supplements and things, and why they don't work long term is probably because people get so stuck in a routine, like doing the same exercise routine, and you're no longer losing weight, or, that you have to mix it up. And it's almost like we have to stress ourselves a little bit. I think we go overboard with stress, but it's interesting that we, by nature, the randomness, I would think we need to stress ourselves in certain ways to keep producing.
Absolutely. That randomness and that stress, sort of scientifically is referred to as hormesis, is demonstrated everywhere. Whether it's exercise, whether it's food, whether it's vitamins, whether it's, the blood pressure pill that I unfortunately have to take every day. My blood pressure goes up, it comes down, it goes back up. Everything that we do, our body responds. We're not we are made of 50 trillion cells with 25,000 genes in each cell, and we are a very complex organism. And a lot goes on behind the scenes that we're not involved in, but it's happening. So we have to constantly remember, too much stress, not good. But little stress is very important for us.
Before we close today, I need to ask, how did you personally become interested in this field?
One serious point, one not so serious point. So serious point, everyone that I've ever loved and lost was taken from me, either by cancer or heart disease or congestive lung disease. And meanwhile, I'm sitting there in a $1 trillion industry, unable to address any of my parents' and grandparents' problems, and seeing them all taken from this world as amazing amounts of wealth came into the industry that I sat in for the last 30 years. That was unacceptable to me. And now I have 3 lovely children and a wife, and they're the future, and I'm going to make it happen for them. And if I wasn't able to make it happen for my parents and grandparents. That's a serious side of why I'm doing this. The non-serious side, or jokingly, I was always a big fan of comic books and science fiction growing up. Yeah. I still love it.
Who doesn't, really?
I read comic books with my sons still. I take them to the movies. We see all sorts of science fiction. I love seeing the potential future, and I want to help create it.
It's amazing to me with comic books when you read it, as a kid, and of course you suspend your belief and you think, wow, that could happen. And then as an adult, you think that could never happen. And now we're coming to a time where we're realizing, no, we were right. It could happen. So it's interesting how some of these sci-fi things that seem impossible are actually becoming possible. So what advice would you give to someone interested in pursuing, say, a life sciences career? How do they get involved with this?
I find it personally the most exciting area of endeavor that one could go after in terms of not just the connection to the natural world and the 3+ billion years of life that came before us, but just in the complexity of it. I could never see myself doing information technology or other, mechanical engineering. I mean, it's a beautiful place to be. Nature never ceases to sort of amaze me as much as I learn about it. And so I definitely promote it as a very promising place to have a career. The one thing I would caution everybody is the fact that when it gets into therapeutics and the pharmaceuticals and all the stuff that I'm involved in, and obviously I have a few decades behind me on this one, it is not as easy as creating a new app. And it is an industry that is fraught with failure and risk. And so I basically say, if you can deal with rejection and failure and keep coming back and wanting to try again, and if you have sort of the Thomas Edison mentality that you'll fail 1,000 times before you succeed, it's a beautiful place to be. But if you can't handle the rejection, if you were the type of person that got upset when you asked somebody on a date and they said no, it's probably not your industry. But if you can deal with it, please. It's a great. It's. I can find nothing more exciting.
So where can people go to learn more about BioQuik and its current research?
Come to our website, bioquik.com. We pretty much list everything that we're doing, future programs, collaborations. And as I always say, reach out. Use the website if you have questions, comments. Reach out to us. We're a small shop, but we're quite open, quite transparent, and we're passionate about what we do. So we're open to talking with everybody and anybody about what we do, collaborative opportunities, anything, because we realize that we're doing cutting edge, bleeding edge work, but at the same time, there's a day doesn't go by that we don't find out about synergistic possibilities with other groups and things that we don't know about. So we're open to hearing from anyone.
Ira Pastor, thank you so much for joining us today.
Thanks for having me, Dan. It's a great pleasure.